Right, I just put the first 3 dots here, and then I think they have something close to kind of like estimate right here. That's I put that as I said this was about 4 because it looked like with my eyeballs it was about a little bit below 5. So that's your first thing. You want to estimate where your y-intercept is. So step 1, estimate y-intercept. By the way, what type of equation is this?
Wait, what if you put 5 instead of 4? Is that going to change?
It might a little bit. You should be close. Like, watch my steps, and like you can emulate with whatever you have. You should get something pretty close. So, what kind of graph is it? Exponential. So there could be when you see these graphs, these scatter plots. I didn't make too much noise. I didn't make noise in this, but all I have to do is add some noise in Python, and it'll start to like look like a real scatter plot. I made this first one a little soft, right? So estimate your y-intercept. I estimated y0 as approximately 4. Just by eyeballing, look a little bit under 5, 4 is pretty close. Next step is to estimate your d. Spot 3. And this logic comes from the fact that if A was 1, so I'm making an assumption A is close to 1. It's not, but it's just a ballpark estimate. If A was approximately 1, then D would be approximately just what the Y0 is, because when you plug in Y0 minus 1. So if you look at the formula for exponential, it's Y equals A B to the X plus D. If this A was 1, then it's B to the X plus D. I can ignore it. And then I plug in 0, and I get 1 plus D. And so this implies D is approximately Y0 minus 1. That's right. I was trying to find an easier way for you to estimate D so then it doesn't give you a headache. I actually tried a few things. Like if you use calculus, I thought, oh, you could just put some tangent lines in there. But this seems like a good idea, and it's not actually. It comes out to pretty complicated equations eventually. So this is like a rough estimate of what D could be. Then step 3 is to choose y1, x1, 2 points. I chose my x1 and x2 to be 1 and 2. And I chose them because then x2 minus x1 is just 1, and your root is not a real root. It's like there is no root. So I chose, you can do the same thing. You choose x1 to be 1. If x1 is 1, I had y1 is approximately 5, a little bit higher. So you might have something larger here if you did this. And then I chose my x2 to be 2. And at 2, it was, I said it's about 10. So these are rough estimates. Then I took the equation that was given to me in the table. There is no root. X2 minus x1 is 1. So there is no square root or anything. It's just to the 1 power. And so you get just, let me put it using your formula. You'll get 10 minus 3 over 5 minus 3. This is the first root, which is just to the 1 power. It's the same thing as 10 minus 3 over 5 minus 3, which gives you 7/2, which is 3.5. So that was what my estimate for B is. So that's step 3. Step 4. Calculate B. And the next step is you're just left with A. Step 5, estimate A. So A is equal to, let me look at, what was the formula for A that they gave you? Because it's something like B to the whatever power, right? I just chose my x1, y1. I use my x1, y1 because my x1 is 1. There is no power. So you have 5 minus 3. Messy work. 3.5 to the 1 power, which is turns out to be 0.57. So my final equation was y equals 0.57. E was 3.5 to the x plus 3.
I got something.
I didn't know that.
I didn't think you
You should have something close.
I got y is like 6.1, or y equals, so the first number would be 6.1 times, and then I got like 1.6 for my b, and I just assumed that b was 0.
How can you check how good your model is? Plug in the next value of x that you didn't use.
It's only slightly off. It's only like 1 or 2 off for every point.
I'll show you what I did, which you guys can't do because you don't have a graphing calculator, but you can check your work by just checking how close your next value is in prediction. So how to check your work if you want to add in if you have time, which is not, I don't think you will, but step 6, check work. I didn't use x equals 3 in my calculation, so I can put x equals 3 in here and then just check what happens when I get 0.57, 3.5 raised to the 3 power plus 3. Does it actually equal the something close to the third value? Men, leave your cell phone behind. Okay. Thank you. Yeah, that's fine. Okay.